Okay guys, welcome back, and now we're going to do exercise 1.5 from the algebra notes. So first things first, you have to memorize each of these properties, as it will 100% be in test 1 and possibly in the exam. Now what you have to understand, alright, when dealing with any of these properties is that the concept of it will remain the same. So A union A will always be equal to A. The only element that may change, sorry, not element, but the variable would be A. And instead of A, we could put X union X, which will equal to X. That's the only thing that changes when we deal with these properties. But the property itself, notice the union of two of the same variables is equal to a union, and the same goes for each of these other properties. Also note, for the purpose of this video, I've just for the above, I've used this sign instead of doing this, so using the actual element sign so that the video can go a bit faster. Okay then, so memorize each one of these properties and you will be good to go. Okay, let's get into it. So with number one, it says which is true and which is false. So if we look at A, it says the set of nothing equals nothing. And so if you recall our steps from set theory, in set theory we check the brackets, we check the sign, and we check the element. Now from set theory we only dealt with two things, being elements and subsets. We never dealt with an equals to a sign. So straight away you know for a fact this is false. Okay, because it's not an element and it's not a subset. And number two, anything that is inside brackets, if you put in a bracket and you close and there's something there, any element, it could be even a shape, it could be a tomato, that's an element of it. So this actually contains something. And the same goes even if it is nothing. Therefore A is false, right? So for B, again, set theory rules. It's an empty set. Notice it's an element. We got our sign. Is it in brackets? Yes. And we know our rules from set theory. In order for it to be an element, the variable which is on the left hand side, being this one, must not be in brackets. And is that the case? Yes. So B would be true, right? Let's make this a bit longer. Okay. All right. And then for C, we see that for any set of A intersection of nothing equals A. That's false. Because our rules, our property rules tell us that the intersection of something and nothing is nothing. Okay, because nothing is basically nothing. Think it's like the air. It's going to be in everything. But something that's, let's say, you think of it as in matter, that's physical, that you can hold, it's going to be placed somewhere. It's not going to be in two different locations. It's not an atom. All right. For D, it says if A, B, and C are set such that the union of A and B is equal to the union of A and C, then B and B is equal to C. That's false. All right, straight away. Reason being is because we can have different sets. We can say that let's do it here. One moment. All right, so let's do this here. We could say that A is equal to 1. All right, and we're going to say B is equal to 2 and 2, and we're going to say C is equal to 2. All right, so from that we know the union of A and B is 1 and 2, right? 1 and 2. And we know the same goes for the union of A and C. It's 1 and 2. But because these are not the same. In order for B to equal to C, both B and C need to have the same variables and the same quantity. And because there's 2 of 2's in B and there's only 1 2 in C, therefore B and C is not equal to each other. Okay? And so then we have, if A, B, and C are sets such that A union B is equal to A union C for every set of A, then B is equal to C. That's true. Reason being is because when they say every set A, it means A is fixed. All right, A is fixed. So you can say A is equal to, let's say, 2. But B and C, the elements in B and C, are continuously changing until B and C are equal to each other, until the quantity and the element is the same. That is why it says for every set A. And therefore, eventually you are going to reach a point where B just has 2 and C just has 2. Okay? And okay, so I'll see you for part 2 and have a good one. Thank you.